Hi guys, welcome back to my mathematics tutorial. My name is Peter C. Dokwa Jr., your math tutor and instructor of mathematics at the University of Liberia. In today's lesson, we want to continue with the combination of the roots. So we're going to combine the power rule, the extended power rule, the quotient rule, the product rule. We're just going to mix them up, but it entails a combination of roots. So it's possible that a problem has 3 roots, 2 roots, 4 roots, and so forth, right? So let's look at few problems. So these are continuations of problems from previous lesson. So the first problem says y equals the square root of 4 over x minus the square root of 3x. Now in this problem, they just told you to find the derivative. So you are not bothered about roots. You already have all of the roots in your head. You're just going now to solve the problem. So rewrite this first in exponent form. So we have 4 over x raised to the power 1 over 2 minus 3x raised to the power 1 over 2. So whenever we see this, we know that we can use the power rule. But because we have another function within, we must use the extended power rule. That is, when we drop this power and minus 1 from this power, we must differentiate inside. If this was just x, then it's just the power rule. No need of differentiating inside, right? But because we have x raised to the power 1 over 2, when we drop this power, now let me explain this. If this is what you have, assuming that you have, assuming that you have x raised to the second power, we drop this 2, right? And we rewrite this x, we subtract 1 from this power, right? It's 1. Then we differentiate inside. The derivative of x is 1. So you see that? Because this is just x, that's why we don't bother to differentiate inside. We just continue. But if this now is 4 over x, it means this will not give us 1 any longer. If this is 3x, this will not give us 1 any longer. So we have to differentiate it. So this is exactly what we call the extended power rule. So let's move on. We have 1 over 2. So y prime now, we drop this 1 over 2 and rewrite 4 over x raised to the power. Now subtracting 1 from here, it's like half. You subtract 1 from half. It's like you have half banana. Then you take half from in. You take 1 from in and half banana. It means you need additional half banana to add to your half to make it 1. So you will be having an outstanding half banana. So it's like someone asks you for 1 banana, you only get half. So you went and borrow, or you went to credit. Let's say you borrow half banana, let's say half banana for another person. So your half plus this half makes it 1. But now you are owing another person. So what you owe now is this negative. Okay, so that's it. That's the shortcut. 2 times 1 is 2, and then 1 minus 2 over 2. So it's just like saying minus 1 over 2. Okay. So we differentiate inside. The derivative of what is inside. Because this is a quotient, we apply the quotient rule. We hold x and differentiate this, we get 0, right? So sometimes if you already know that you're going to get 0, you don't even have to write it. But let's do it. So you get 0 minus. So you have to memorize the rule. The quotient rule says minus. You hold 4 and differentiate x, you get 1. Then the rule says you must square the denominator. So we're done with this one. We'll move to this second term. Minus, drop the power 1 over 2, 3x, subtract 1 from the power, you subtract 1 from in half, you get negative half, right? Then you differentiate inside. The derivative of 3x is just 3. So y prime now, you have to simplify. So because it is negative, you can reciprocate. So this gives you this x going up. So it's x over 4. This 2 is still downward. 1 over 2. Raised to the power positive half, right? And then this is 0. So this now becomes minus 4 over s squared. Minus 3 times 1. So it's 3 over 2. And then this 3x raised to the power positive 1 over 2. No. Okay. So we can just simplify further. So this 4 can cancel this. Sorry, this 4 not. You have to, the square root of this is half. So the square root of 4 is 2. So 2 times this 2 will give you 4. So you can cancel, right? So you're left with the square root now. X raised to the power 1 over 2 all over x to the power 2. Because this 4 and this 2, you'll be left with 2 right here. The square root of this 4. Now there's a square root of this 4. There's a square root of 4 because you have square root of x over square root of 4. There's it. So that's the reason why we did that. So next we can simplify this side. Okay. So that side is already okay. We just want to further simplify the problem. So we can reduce this and this as well. So x raised to the power 1 over 2 minus 2. So 2 times 2 is 4. 4 minus 4 negative, and then positive 1 is minus 3. So this gives us minus 3 over 2 equals this minus 3 over 2 times 3x raised to the power half. So we can just say this denominator times this one. Just a shortcut better. Not to go the long way. So this time this gives us minus 2 x raised to the power minus 3 over 2 times 3 raised to the power 1 over 2 times x raised to the power 1 over 2. Because it's 3x, you can open them up. Minus 3 all divided by 2 times 3x raised to the power 1 over 2. So I'm just simplifying the problem further. That's all. So what else? We have this coming on this side, minus 2 the root of 3. So this x and this x, the bases are the same. You add the powers. So it's minus 3 plus 1 all over 2. This gives us minus 2. So it's just minus 1. So it's x raised to the power minus 1. And then minus 3 all over 2 times the root of, let's keep it 3x raised to the power half. So again, we can simplify this one right here. Is minus 2 the root of 3 all over x minus 3. So if we multiply this and this, there's an expression down here that is called 2 times 3x raised to the power 1 over 2. So this and this will give us minus 3 the root of 3 minus 2 the root of 3 minus 3x and then divided by x times. So this is already divided by this expression. So if we reciprocate, it becomes 1 all over 2 times 3x raised to the power 1 over 2. So finally, what can we get? We have negative 2 the root of 3 minus 3x all over 2x times. We can also expand this one. So this can be the root of 3 times x raised to the power 1 over 2. So this x raised to the power 1 and x raised to the power 1 over 2, we add the powers. So it's like 2 times 1 is 2. 2 plus 1 is 3. So this gives us 2 the root of 3 and then x raised to the power 3 over 2. And then this is 2 the root of 3 minus 3 times x. So we just try to simplify it further, right? So you can stop where we stopped initially, so you don't have to come as far as this portion. So let's move on. We have many problems to solve. So the next problem says f of x equals 4x squared minus 3 raised to the second power x plus 5 raised to the third power. You were just asked to find its derivative. So you know that you have a product. This times this. But the first product is raised to a power. The second product is also raised to a power. So it means when you're dealing with this, you have to bring this power down, reduce the power by 1, and also differentiate inside. Likewise with this one. So f prime of x is equals. So product rule says we must hold the first factor and differentiate the second, right? So we hold the first factor, which is 4x squared minus 3 raised to the second power, and then we differentiate the second. So the derivative of x plus 5 raised to the third power, you just have 3 times x plus 5 minus 2. Let's say minus 1. It gives us 2, right? And then times the derivative of x is just 1, so we don't have to further do that. Plus, so we held this one first and we differentiated this. Now we want to hold this one, which is x plus 5, and differentiate this one. So again, we drop the power 2, rewrite the expression within the parentheses, 4x squared minus 3. Subtract 1 from the power is just 1. Then we differentiate inside. The derivative of 4x squared. 4x squared. 2 times 4 is 8x. Derivative of this gives us 0. So we are done. So we have f prime of x. We just simplify now. 4x squared minus 3 is here. 4x squared minus 3 is also here. But it's raised to the first power here, and here it's raised to the second power. So we take the first power. 4x squared minus 3. We just simplify further. Times x plus 5 raised to the second, x plus 5 raised to the third. So we take x plus 5 raised to the second. These are two terms that we have. So x squared, 4x squared minus 3, 4x squared minus 3 raised to the first power. So we left with just 4x squared minus 3 times Okay, so it's just 3 times 3 because x plus 5 raised to the second power is already outside. Plus x plus 5 raised to the third power, this is second, so you're left with x plus 5 raised to the first. This is 2. 2 times 8 is 16. 16x. And then 4x squared minus 3. 4x squared minus 3 raised to the first power is already outside. So we just simplify in there. So this one will give us 4x squared minus 3 times x plus 5 raised to the second power times, so we multiply. So this is 12x squared minus 9 plus 16x squared, and then plus, so 16 times 5. So it's 5 times 6 is 30. And then 5 times 1 is 5. 6, 7, 8 is 80x. So we just simplify in there. We have f prime of x equals to 4x to the second minus 3 times x plus 5 raised to the second. So we take the highest power, the second power. So this and this gives us this 10, 20, 28 x squared. And then this is plus 80x and minus 9. So this is it for the second problem. So let's quickly run over. Next problem says y equals to the root of x minus, so that root now we just rewrite it as 1 over 2 or over x squared plus 1. So again, we use the quotient rule. So y prime gives us x squared plus 1. We hold on to this and differentiate this. So in differentiating this, we drop the power 1 over 2 and rewrite x minus 1. Subtract 1 from this power, it gives us negative 1 over 2. The derivative of what is inside is just 1, so there's no need. So we have differentiated this portion. So we say minus, we rewrite the numerator, x minus 1 raised to the power 1 over 2, and we differentiate the denominator. Derivative of x squared is just 2x. Divided by x squared plus 1, then we square it. So we can just simplify now. So we have y prime equals, this is x squared. Now this is negative, so we can reciprocate. So up here is x squared plus 1 all over 2 times x minus 1 raised to the power 1 over 2 minus x minus 2x times x minus 1 raised to the power 1 over 2. So this whole thing must be divided by s squared plus 1 all square. So if we just multiply this by this, we're going to have x squared plus 1, 2 times 2, that is 4x. And then this radical times this radical, we take the radicand, which is x minus 1, divided by this denominator, which is 2 times x minus 1 raised to the power 1 over 2. And then we reciprocate this and change the sign. So what will we get if we reciprocate this? This will go in the denominator, so it becomes s squared plus 1 raised to the second power. So y prime now equals, we can simplify. This is 4x squared and then positive 4x right here. So this one, that's it. 4x squared plus 4x. So x squared minus 4x squared gives us minus 3s squared. And then plus 4x plus 1 all over 2 times x minus 1 raised to the power 1 over 2 times s squared plus 1 raised to the power 2. So this is also how we find the derivative of this particular expression. So let's move to the next one. Question 11. So we have g of x equals x raised to the power 1 over 2, 1 over 5 times 4x minus 1 raised to the power 3 over 5. So g prime of x, now we use the product rule because you have one factor and another factor. So we hold the first factor without differentiating, and we differentiate the second factor. So to differentiate this factor, we have to drop the power 3 over 5. We rewrite 4x minus 1 and subtract 1 from this power. So it's 5 times 1, 5. So it's 3 minus 5 over 5. So this gives us minus 2 over 3 over 5. Then we differentiate inside. The derivative of 4x is just 4. So we are not done. We held the first one and differentiated this. So we must now hold the second factor, which is 4x minus 1 raised to the power 3 over 5. And then we differentiate x to the power 1 over 5. So x to the power 1 over 5, we just drop 1 over 5. We rewrite x, subtract 1 from this power. 5 times 1 is 5. So it gives us minus 4 over 5. So our objective now is to just simplify this problem. So we have g prime of x equals. So we look here, and the negative power, we send it in the numerator, in the denominator now. So it's 4x minus 1 raised to the power positive 2 over 5. Because the power is negative, goes down, it becomes positive. So in the numerator, you have 4 times 3, 12. So it's 12x raised to the power 1 over 5. And in this denominator, you also have 5. And what is left on this side, you have this to be a negative power. So it goes down in the denominator, x to the power positive 4 over 5. And then you also have 5 down here. So this is 4x minus 1 raised to the power 3 over 5. So the LCD, we find the LCD for the two expressions. So the LCD would just be this denominator times this denominator, right? But the 5, we don't have to multiply it twice. So it's just 5x raised to the power 4 over 5 times 4x minus 1 raised to the power 2 over 5. So that's the LCD. That is, each of these denominators can come from within this LCD. So we say the first denominator goes into this LCD. 5 and 5 will go out. And then this will also go out. So we'll be left with x to the 4th power, x to the power 4 over 5 times this. So it's 12 times x to the power 1 over 5 times x to the power 4 over 5. That's the first one. Plus. So if this goes into this denominator, this cancel, you're left with this one. So it's 4x minus 1 raised to the power 3 over 5 times 4x minus 1 raised to the power 2 over 5. So g prime of x equals this 12 x to the power 1 over 5 times x to the power 4 over 5. You add the numerator, the powers. So the same denominators. So we just say 1 plus 4 is 5. 5 over 5 is just 1, so it's just x. And then this one as well, the bases are the same. You just take 1 and add the powers. So 4x minus 1. So the power is 3 over 5, 2 over 5. So it's just equals to 1 as well. Divided by 4, not 4 now, but 5x raised to the power 4 over 5 times 4x minus 1 raised to the power 2 over 5. So what is this equal to? This equals to 12x plus 4x is 16x minus 1 all over 5x to the power 4 over 5 times 4x minus 1 raised to the power 2 over 5. So this is our final answer. So we do the last two. Maybe we'll just do the last one and then you can now practice the other one. So h of x is equal to x squared minus 2 all over 2x squared plus 1 raised to the power 2. So we can decide to say, let's rewrite it as x squared minus 2 divided by 2x squared plus 1. Or let's say we can decide to rewrite it as x squared minus 2 raised to the second power divided by 2x squared plus 1 raised to the second power, right? Or we do it as it is. That is h prime of x. We drop this power, right? Bring 2 down. We rewrite this expression x squared minus 2 divided by 2x squared plus 1. We subtract 1 from the power, we left with 1. Then we differentiate inside. So the derivative of what is inside, we use the quotient rule. So we hold the denominator, 2x squared plus 1, and we differentiate the numerator, which is just 2x. Minus, we hold the numerator, s squared minus 2, and we differentiate the denominator, 4x. Divided by, we rewrite this denominator, 2s squared plus 1, and we square it. That's how simple it is. So we simplify now, h prime of x is equal to, just simplify what we have here. So we have 2x squared plus s squared minus 2 divided by 2x squared. So 2x squared plus 1, and then 2x squared plus 1 raised to the second power. So we would just have 2x squared plus 1 raised to the third power. So let's work in there and see. This 2 times 2 is 4x to the third. And then this is plus 2x minus 4x to the third. And then this is negative is positive. This is 8x. So this and this go out. We have 2 times x squared minus 2 times 2 plus 8 is 10x all over 2x squared plus 1 raised to the third power. So this will just be equal to 20x times s squared minus 2 all over 2s squared plus 1 raised to the third power. So that's it for this problem. And then this last problem will just be handled in this way. So we have 3x squared plus 5 raised to the power negative 3. It's just very easy. So y prime, we drop this power, which is minus 3. We write what is inside. We subtract 1 from this power, so it gives us minus 4. Then we differentiate inside. 3x squared gives us 6x, and then the derivative of 5 is 0. So we just multiply this and this. Y prime is equals, this is negative, 3 times 6 is 18x, and then this power is negative, so we send it down in the denominator. So it's 3x squared plus 5 raised to the positive 4. So thanks all so much for watching. Please subscribe to our YouTube channel, like our videos, share the videos, and see you in our next lecture. Next lecture will be very interesting. See you.